First, I'd just like to thank PrimeKey for giving me the opportunity to come here and talk. So today what I'm basically going to be talking about is where we're sort of looking at taking the Bouncy Castle APIs. This is really, how do I put it, what we're proposing to do. And I'd certainly welcome feedback from anyone, either in question time or lunch or during breaks or whatever for the rest of the day, who might have some ideas about what we should be doing as well, because we do really rely on, as an open source project, we do rely very heavily on our user community to give us some guidance. Okay. Right. Now I know which direction it goes in. Is that? Right. Okay. So, yeah, I'll just start off by talking a little bit about the history of the project. Started in 2000 during the time of the crypto wars. So for those of you that were around then, you probably remember that Sun actually had to release the original version of the JSSE as an academic paper at a conference. They weren't even allowed to publish the Java doc. The other thing that happened at that time was the J2ME profile came out, and a couple of us were actually quite interested in what the possibilities were using the J2ME, so programmable phones were just starting to appear. We started out with just the Java APIs. C# arrived in 2004. The code base was quite small, 27,000 lines. It probably took us a couple of months to put the first version together. We recognised at the time the importance of certificates. That was kind of the one of the big problem areas, because the certificate industry at that time was quite sort of monopolistic, I think is the word I'd use. And the other thing was, because of our interest in trying to jam stuff onto incredibly tiny JVMs, we were also very interested in elliptic curve. So we've almost always supported elliptic curve. Okay, now we get to now. Things have changed a bit. 314,000 lines of code for Java, C#, 170,000 lines. The Java code base now is well above 500,000 if you actually include all the test cases and everything. We do multiple builds across different VMs. I'll go into some of the reasons for that a bit later. We've got FIPS certified versions now for both Java and C#, and we've currently got a FIPS 140-2 update going through for Java. We've established a charity to actually provide ownership of the code base. The main reason we did that was because, as you can see, the number is a little bit large, and if you're trying to actually do something like this as a weekend project, it's just not going to work. So a few of us are now working on it full time, but we needed some way of both making sure people got paid and also at the same time kind of preserving the original, honouring the heritage of the code base, if that makes sense. So the Legion of the Bouncy Castle Inc, who I guess I'm speaking on behalf of today, I'm actually their secretary. That is a charity. It's registered in Australia. It's a licensed fundraiser. Crypto Workshop, on the other hand, is a proprietary limited consulting company. And that's basically the mechanism we get paid for, because you can imagine, even with very, very flexible laws in regards to conflict of interest, it's very hard to be running a charity as a trustee whilst at the same time making remuneration decisions about yourself. Well, it's hard to do that and appear to be doing the right thing. Anyway, so that's kind of the way that all works. So what we're now trying to do, in terms of, we've been basically slicing up what work's available and trying to work out what things need to be done. The JSSE, of course, is one of our big things. Also, certificate revocation started changing in Java 1.8, so we're kind of working at that too. The reason the JSSE is such a hot item, of course, is because of TLS 1.3, but also protocols like EST and that which have been used for certificate request creation and stuff like that actually require features of the TLS protocol which aren't actually accessible directly from the JSSE. The other thing that happens is that the JSSE that actually ships with the Oracle JVMs and the OpenJDK does have what they call a FIPS mode. And essentially what the FIPS mode in that situation does is it actually limits the cipher suites to the ones that are allowable under SP 852, less the GCM ones. But it also actually introduces other restrictions which probably made a lot of sense to Oracle, but they actually make no sense to any of our users. So for example, you can only use an Oracle Trust Manager, whereas one of the traditional ways of actually managing your trust managers, if you're in a corporate kind of environment, is you actually plug them straight into a database and then get your validation and everything happening that way. And then yeah, things like OCSP, that is also a feature of 852. OCSP stapling, of course, is good for privacy. Again, the API for that, although that's actually started appearing in Java 1.9, is very confusing at the moment. So we're actually, we've actually added that to the lower level API in the JSSE, and we're also looking at trying to find some way of putting into the JSSE as the actual Oracle-based API stabilizers. So, TLS 1.3. All right, who was expecting it to be out before the end of this year? Seriously. Yeah. Oh, yeah. So, yeah, it's now in a... actually, I might just take these off. I think it's easier if I look straight ahead. It's now in a draft 21. So, in some countries, it would even be old enough to drink. That expires in January 2018. There's a lot happening in 2018 though, in January, especially around TLS. Yeah, what can I say? We're keeping an eye on it. There have been a couple of protocols that have emerged that are stable. CHR20 with Poly 1305 is an example, and we actually support that already, although I wouldn't go as far as to say that we actually support TLS 1.3. The other things, of course, we're looking at is Edward curves and also curves like 25519, the key exchange that's built around that and everything. We're continuing to look at FIPS, NIST, despite the fact that they almost have resourcing issues as bad as ours, is showing no signs of stopping. There's still work going on around the SHA-3 standards, new algorithms that have been made possible by the sponge structure and all that. CAVP is actually moving towards doing automatic algorithm testing. So the idea really is that you communicate with a file server, which you upload a profile of what your actual module is meant to support, and it'll generate the test vectors for you and send them back to you, and then you send it back as a response. So the current situation, which is very, very manual, where basically what you do is you fill in a lot of forms, which you then give to the lab, which they then type into 100 screens in a CAVP tool, and then they press the go button and these vectors get churned out. And then they send those back to you, then you feed them into your application, and then you send the results of those back to the lab, where they then load them back up into the tool, which then chugs away, validates them, and eventually hopefully produces a yes. That's all going, which is good. We're also trying to do more work towards actually automating testing of the module for operational purposes. So there's actually two levels of testing you have to go through even with the software module. So PrimeKey's device, for example, has been certified to level 3, but in our case, as we're a software-only module, we're getting certified to level 1. That still requires the CAVP testing to prove the correctness of the algorithms. And then there's what they call the CMVP testing, which in our case just means showing that if there are cat failures or anything like that, the module will actually refuse to start. They look at things like zeroization, whether in approved mode specific functionality is blocked like it's supposed to in the security policy, all those sort of things. The first time we actually did that, the lab technician sat down with the Java debugger in IDEA and single-stepped through each test vector. It just took days. So yeah, we've actually got a way now of actually automating that. And the main reason we're doing that is because what we're finding in terms of keeping the project going is that one of the things that a lot of vendors have picked up on is that they can actually take our code base and either certify a subset of it or the entire thing for their own purposes. So basically this code base is going to get certified a lot, and anything we can do to make it easier all round benefits all of us. And yes, the post-quantum competition's on. I'm going to be banging the post-quantum drum a bit. I'm sorry if I sound like I'm repeating some of the other speakers, but yeah, I cannot emphasize enough just how serious the whole post-quantum thing is. And then, of course, there's FIPS 140-3. I don't know if it's got something to do with the fact it ends in a 3, but it's running a similar curve to TLS 1.3 at the moment. There's probably a bit of a competition to see which one of them comes out last. At the moment, they're both winning, though. We haven't really looked beyond FIPS. There's been a little bit of talk about doing common criteria, and we have actually had several users who've done common criteria by basing it on the actual FIPS module. So FIPS is quite a good springboard to other certifications. Most countries have their own sort of profile, which again often looks very much like FIPS with a couple of tweaks. The issue we've really got there is that we're probably not going to be doing that ourselves, just simply because we just don't have the resources to stay across that sort of thing. Although, yeah, as I said at the start, we're certainly open to discussions on it. And I mean, we do talk to people who are going through different certifications to try and help them interpret the documents that they're actually trying to get through. Okay. So the other thing that we've got going on now that we've actually gone through this whole certification process and that we've gone through the doing the update, well, almost gotten through doing the update. We've actually been trying to migrate a lot of the things that we've learned from FIPS into the general purpose API as well. Yes, the FIPS experience is quite interesting. Oh my God. Like at the risk of sounding like we were a bunch of clueless idiots who had no idea what we were getting into, I'd probably say with hindsight that we were a bunch of clueless idiots who had absolutely no idea what we were getting into. Yeah, it took 3 years. I mean, that pretty well tells you everything. Now, when we designed BC originally, of course, we were trying to take advantage of, as I said, the small platform, and what that really lent itself well to was having a very compact API which allowed you to plug and play a lot with ciphers, modes, and things like that, without any consideration for whether or not it was in fact a good idea to do so. So the basic BC API is quite flexible. Now, for FIPS, of course, this was a complete curse, which meant that we had to rewrite the entire low-level API to actually produce something which we could then certify using FIPS, just due to the what they refer to as the boundary requirements, which is essentially an idea that you have a wall that you can't cross. So there's a lot about the actual NIST standards and the way they're actually phrased, which are really about trying to protect developers from inadvertently introducing errors. Now, we have realised that in some ways it's not a bad idea, and the Core Infrastructure Initiative, which is part of the Linux Foundation, has actually introduced a Cll Badge Program. So we've actually started looking at that. Now, the CII Badge Program is basically best practice. what best practice means in this context is primarily you can say, I just want everything to be at least 112 bits of security, and if I try and invoke some functionality which is lower than that, so 112 is currently FIPS's NIST's sort of bottom line. If I try and invoke something like anything that's below that, I don't want it to work, or I want you to at least tell me, or I want it to explode. With crypto modules, exploding is generally the best option, because if people are doing stuff like that, you just want to stop, get them to fix it properly. But yeah, it's not as draconian as FIPS. You don't have to worry so much about things like boundary. There's a lot more algorithm flexibility. They don't mandate a particular set. For 112 bits of security, for most symmetric key algorithms, it just means you need to have a symmetric key that's at least 112 bits. Obviously, there's no issues with what kind of curves you support and all that sort of thing, providing you've done the math properly to work out the security level. It can accommodate weird things. So if you've actually got a legacy application which for some reason still requires MD2 or MD5, you can do it. You can actually set things up so that that's allowed. Whereas if you presented a security policy to NIST which said I want to use MD2 in approved mode, they give you that sort of look which is like the one you get when somebody goes, "You're a funny guy." Funny. No, it's not going to happen. And yet, the other nice thing about the badge program is it doesn't really require us to fully re-engineer the Bouncy Castle API like we did for FIPS. So we should be able to do it in a fashion which means it's actually still going to be backwards compatible with everything people are currently doing. And we'll be able to actually slot it in so that it's really just an option that you either turn on or ignore if you just don't want to use it. And the main reason we want to do this is that it would improve certainty, because one of the other things that's come out of the whole FIPS process is as the FIPS user community is built up, we've had people coming to see us with questions about why certain things are blocked and things like that. And while sometimes those questions are really related more to the fact that suddenly you've gone from an environment with very few boundaries to one that's actually very tightly restricted, there are other times when what people are actually approaching us about and what they're actually doing at the moment is just simply incredibly scary. So we realised that actually being able to provide something like this where we can just go to people, look, if you're trying to write something that's secure, tick this box in the API and then it will at least give you some idea of what you're doing if you're doing something wrong. We have actually begun to appreciate the fact that that's probably quite a good idea. So the other thing we got on our wish list is mathematics. Yeah. The Java APIs basically, of course, support big integer. We have our own C# big integer library, which isn't quite as problematic as the Java one, but there's two ways of writing a big integer library. One way is where you go, okay, I want a big integer library that's going to be as performant as I can possibly make it, because the basic idea is I just want numbers to go through really, really fast. And then there's the other way of doing it from the crypto perspective, which is I want to make sure that I'm going as quick as I can, but if I've got a choice between leaking all the bits of my private key due to the amount of time a calculation takes and going a bit slower, then I'd rather go slower. Now, the big integer library in Java, of course, is written from the I just want to go really, really fast. The second funny issue with the big integer library is that while it supports functions like mod power, for example, because doing the actual power operation and then doing the mod is incredibly slow, but now combine those, there are a lot of calculations for things like elliptic curve and that, which would require longer and longer functions than that. And if we could actually encapsulate those into single operations, then obviously the EC library would actually go quite a bit quicker. And we'd also have the advantage of actually being able to make sure that the thing was at least running in constant time. So algorithms, yeah, ephemeral keys, forward secrecy are all the rage now. We want to add more support for dual key Diffie-Hellman. So at the moment we support ECMQV, for example. As we're all aware, there are some patent issues around that. There are alternatives to ECMQV, which work just as well. So we're in the process of adding those. Edward curves, as I said before, at DSA. NIST are really excited about the possibilities with SHA-3, so we now have SB800, 185. So C-shake, KMAC, tuple hash, parallel hash, which are all new ways of actually using the sponge function to generate keys. And then, yeah, also we're trying to manage a range of international standards as well. We've just actually added GOST key exchange. We've got a reasonably complete implementation of the Chinese algorithm set as well. The Ukrainian DSTU standard, we've done a bit of work with some of the French curves, things like that as well. So just keeping track of those. It's pretty much a full-time job. Protocols. Look, yep. We've just done some work for supporting EST. One of the things that sits under EST is CMC. We're looking at doing wider work to actually support those functions cleanly. TLS. Yeah, look, you know, if we do this talk again in 10 years' time, I'm sure it'll probably be a draft 2005, but it'll be coming out next week. Ongoing work with certificate management protocol. I don't know how many of you are familiar with certificate management protocol, but it's almost like PCS CS12 in its agility. You can basically do anything in it. But that does make for a very complicated API, so trying to basically find ways of making sure that API interoperates with other people's implementation has turned out to be quite complicated. And yeah, basically standards are going to change, and part of this is actually due to what's coming on the cryptography front. Static keys are becoming quite problematic. As I said, we want to add the extra CAS stuff. And basically, the one that everyone, of course, is talking about is quantum. I was a complete quantum skeptic a couple of years ago, really. You know, I read the paper where they managed to factor 15 into two numbers and they got 4 and 5. I thought, well, you know, it's close, but you know, I don't see any reason to panic. Anyway, last year at ICM CI in Ottawa, I went to this talk by someone from the French group, and he got up and said, we're going to have a quantum computer in a lab that'll factor a 2048-bit key within 5 years. And I thought, oh dear. And I went to see him, and he described what they were doing and how they didn't have a clue what they were really doing, but they were just doing the experimental physics thing of trying different things. And because I went to uni with a lot of experimental physicists and drank with a lot of experimental physicists, I realised that he was probably telling me the truth. So I don't know if we'll actually see one of these things in 5 years, but I'd probably say 10 is starting to sound pretty good. The NSA released a memorandum at the start of last year saying they were expecting that within 10 years at the start of last year, if you had a spare $1 billion to throw around, you probably could find enough disgruntled postgraduates to build you a quantum computer if you needed one. So we're pouring a lot more effort into the post-quantum APIs. Bouncy Castle has support for Michelise, which is based on coding. Rainbow, Sphinx, XMSS and XMSS-MT, which are both actually, they're in an RFC now that's in draft. We've actually been working with the authors of that to provide an implementation. Of course, just having those algorithms implemented there isn't enough. You want to be able to do things like generate certificates with them, use them as the basis of key agreement protocols, use them inside things like cryptographic message syntax. Possibly even one day start using them in something like PGP. Obviously also if you're generating certificates, then immediately you need to be able to use them in things like CRMF, certificate request protocols, EST, all those sort of things as well. And that gets a little bit different. Now I'll kind of give a demonstration of why that is why that is the case. One of the really weird things, of course, is the key sizes. Trying to keep the key sizes of some of these things under control is crazy. In the BC key stores, the BCFKS key store, which is our FIPS compliant one, we had a limit on the size of a CCM packet that could hold a key. It was 128K. I mean, it's hard to imagine a private key being bigger than that, isn't it? No. No. We've actually had private keys that are a meg under the sort of XMS at MT. If there's enough state in the private key, it gets huge. So yeah, you get all these unexpected things that kind of break in the API that you're just not expecting. Yeah, so the basic facts and what's motivating us to do this is the reality is, yeah, it takes 5 years to write a standard. So when you look at somebody getting up in front of a crowd of people at a standards conference, and particularly FIPS standards conference, where it takes a good 7 or 8 years to write a standard and saying we're going to have a quantum computer within 5 years, it's just not great news. Watching developments in this area, yeah, even if you're still a bit skeptical about it, it's obviously one of those things that's on the radar and you really need to be paying attention to it. And yeah, as the crypto agility talk was talking about yesterday, one of the things about this whole thing is that, you know, we've all been in this sort of nice, sweet environment where SHA-1 has been around since the 90s, you know, DES was, I don't know, late 70s. RSA comes from the 70s. I mean, we've been using these algorithms, we've been relying on them. Obviously, SHA-1's become quite a problem, but I mean, it's 2017, you know, you can kind of wear that. It's taken it almost 30 years to wear out. That's obviously no longer going to be the case. One of the great things about post-quantum algorithms, which I quite enjoy personally, is that after doing a lot of research on what the difference between something that was suitable in a post-quantum world compared to something that was in a pre-quantum world, the fact of the matter is that what distinguishes a post-quantum safe cryptography algorithm is that nobody's actually thought of a way of breaking it with a quantum computer yet. There are some mathematical principles that they believe they can use, but the level of certainty that we had previously with algorithms which were based, say, on the discrete log problem, which had centuries of maths behind it and things like that, aren't necessarily there anymore. Novel technology tends to breed novel solutions, novel ideas, novel approaches. There may be ways of attacking these things using quantum computers which haven't even been considered. So, what to do in the meanwhile? One of the things that people are worried about, of course, is the lifetime of encrypted data. If you're worried about messages getting intercepted and then stored and people attacking them a number of years later, while at the same time you're going to a client, this data should at least be safe for 10 or 15 years. You really need to find some way now to start actually hedging your bets a bit by making it just a bit harder. So people are actually looking at hybrid algorithms. It means using key exchange algorithms, because algorithms like RSA, obviously, well, you lose forward secrecy anyway. But yeah, with something like RSA, basically the dog bolts. You could use chems, but that would be about it. So one of the issues, of course, for us, now that we've gone down this FIPS path, is that, of course, if we try and include anything like this in the API, we have to find some way of doing it in FIPS that's acceptable. It turns out in the FIPS standard, there's this thing called the sup priv info field, which is essentially just a byte array of data that gets included in the key exchange process. So what basically happens in a key exchange is some mathematical function takes place on two sides. Both sides produce the same number. That number plus some other stuff gets fed into a derivation function, and the result of all that is a key. So the sup priv info field is the other stuff. So this is an example of how what you kind of have to do if you're actually trying to sort of quantum harden an elliptic curve based key exchange. I'll just have to put my glasses on because I cannot read this. I hope you can. I apologise for the Java if people don't like Java, but oh, wait a sec, let's go. All right, so it's fairly simple. You got this key agreement is the New Hope one, which is the actual post-quantum algorithm. This key agreement down here is your traditional elliptic curve Diffie-Hellman. CKDF is the FIPS key derivation function that gets used. And then we've got this thing here, which is the user key material spec, which in the Bouncy Castle APIs is the mechanism you use for actually passing that extra byte array of stuff. So all we're doing here is we're just passing the generated secret. And then the actual key agreement finishes here, and we get our secret out. So in this case, we're just generating an AES key. Now, of course, the other thing we do here is we actually have to return the public key that's generated as part of the, we return the public key that's generated as part of the whole New Hope thing. Then on the other end, we pass in, wait a second, what am I doing? Yeah, on the other end, we pass in the other party's public key. We have a New Hope private key for this agreement. Do the same calculations here. Then do the elliptic curve key agreement. Again, you can see we're actually using the New Hope key agreement. And then you return your agreed key. So the nice thing about this from a NIST point of view is this is the bit that they've currently decided is secure already, that process there. This bit here is basically stuff you get to decide about. If I was actually doing this in a FIPS context, there would be a couple of other values here as well. I mean, I've done it like this just so to show how simple it is to actually introduce this post-quantum algorithm as a secret generator. But yeah, so for them, it doesn't really matter whether or not this algorithm's secure. What matters is that you're doing this. For people, though, that are trying to squeeze a bit more life out of the packets that are involved in this generation, should the traffic have been captured and intercepted later, and somebody attempts to attack it later, they're trying to take advantage of the fact that by adding this value here into the key stream, when this key is actually generated, even if someone can actually work out what the private key should be for the elliptic curve key exchange, and someone can actually break that, they still can't actually work out what the secret key is because there's no way they can recover this, unless there's something badly wrong with New Hope, which is unlikely, but as I said, new technology breeds new ideas. There's another interesting thing about these two examples though. So anyone who's used to using Java would have realized that this null looks very, very odd. And the reality is, in a key exchange algorithm like New Hope, which is based on an area of mathematics referred to as ring learning with errors, which is a kind of lattice theory, one party doesn't actually have a private key. So the other issue with post-quantum, which is why it's worth starting to look at the implications of this now, is that these algorithms are not the same as the algorithms we're used to using. You have situations where only one party has a private key, but you still have two public keys. You know, these aren't, by our standards, these aren't actually regular protocols. All right, back to us. So, just in general, we're just getting on top of this whole FIPS thing. Um, you know, open source development tends to be very agile. It can be a little bit goofy, although once you get into a crypto API that everyone's using, obviously the goofiness has to go pretty fast. Although we still do goofy things on the side, just so that we don't completely lose touch with our origins. And then, of course, there's all these government processes. So, as an open source developer, of course, I want to spend 5 hours filling in forms for certification, and then a month and a half writing a security policy, and another few weeks going through the whole coordination phase with NIST, justifying the decisions I made. These are the things that any open source developer will tell you they love. Documentation. It's like, bring it on. Bring it on. Yeah. So there's been an adjustment phase, and we're still coming to grips with that. One of the interesting things about it, if you're an old school developer, is, of course, open source is agile. Certifications, on the other hand, are kind of big up front. And yeah, it's a very familiar scenario. This takes me right back to the early days of computing, when if we're familiar with the term the waterfall technique. And the thing you have to be careful about with this is that one of the reasons so many of us ended up working to Agile is that you work out after you've done a few waterfall projects that even a dead fish can go over a waterfall. So it's really, really easy when you just take a situation where you've got an upfront spec to go off and implement something that's completely useless as far as the user or the actual target application is concerned. So we're still sort of trying to find some balance between that, because of the hardware nature of the NIST stuff and the fact that a lot of these processes that they actually need you to follow sort of have their origins in the 50s. You have to be able to make allowance for the way they need to do things and the way they need to see things being done. But at the same time, you want to be able to take advantage of the agile processes to maintain your quality. Yep, there we go, 3 years. I actually put it in writing, how about that? The other big change, of course, that happened was we're now working on, whoops. The other big thing that happened, of course, is that we're now actually working on the project full time. Because, the work that's required, you just can't do it with part-time developers anymore. So there's actually 3 of us working on the project full time at the moment. That's probably not enough, but as the business builds, we're basically slowly bringing in more and more regular BC contributors. That's our current ambition anyway. One of the other things that's happened is IBM, for example, changed their big integer library. There's been rather strange things going on the fringes of some of the Java virtual machines. So we've now actually found ourselves in a position where our build system needs to run across multiple JVMs to do regression testing and stuff correctly. As I said before, there's things changing in the JSSE at the moment to catch up on the fact that there hasn't really been any work in Oracle or Sun before them. There was very little investment in the JSSE, and that's starting to hurt them. At the same time, we're also trying to address those issues ourselves for our actual users, but we're also trying to make sure that it's possible when the JSSE API finally catches up, we can actually provide a reasonably smooth migration. Automate, automate, automate. It's the answer to short resources. Also, weird situations. I had someone come to me with a problem a while ago because they were using the crypto provider in the boot class path of the JVM. Sure. Never occurred to us. It was one of those fringe class loader issues. If you weren't used to the vagaries of the Java class loader and you weren't the kind of, like, I probably should get out more, but I'm the kind of person that'll actually read a JVM spec. I won't necessarily enjoy it, but I'll still do it. If you're not actually familiar with some of those vagaries, you end up in an awful lot of trouble. The other thing, of course, is export control laws have been progressing. The laws in Australia used to be quite different, especially in regard to ephemeral exports. That got changed 2 years ago. The other thing that's happened, of course, is this document appeared a year or two back, and it's actually to do with what's expected of you if you're subcontracted to an organisation that's handling unclassified secured data. Now, because of what we do, we don't really do that. I mean, we're API developers and all that, but we are actually in a position, because we're selling people support contracts, we've effectively become subcontractors. Now, at the moment, our build server actually sits on my desk at home. We have the firewall protecting traffic coming in from the house, and then there is the fur wall, which is the cat. He sleeps in front of it where the fans are. That box has never once been broken into, so he's done an outstanding job. But the reality is, even after several readings of this document, I have not found any references to cats protecting file servers. It seems that you actually need to have an office that's at least got access control, and you need to have a machine room that's at least locked. So we've actually just hired some office space in Melbourne, which is kind of exciting. That was about 2 weeks ago. And we all went in there on the first day and then sat there and looked at each other and thought, wow, this is so strange. But yeah, when I actually got on the plane to come here, we'd finally gotten to the point where we'd actually started working again. So yeah, as I said before, lunch is soon. If anyone's got any comments about things that they'd like to see in the API or any of the directional statements that I've kind of made here, I'd be very happy to get some feedback. Are there any questions? Yo. For which validation? Yep. We're currently doing that at the moment. We got access to the test server last week. There was a process. There's always a process. There was a process though that had to be gone through to actually get access to that. So we've already. The system actually takes JSON, so we're already generating correct profiles on that as far as we can tell. But I expect that when I get back, I'll probably find out if we're actually generating the vectors and responses correctly as well. We've sort of toyed with the idea of trying to write some adapter from the old format to the new format, but it really looks like the best way to do is you just basically ditch all your previous CAVP work and just work with the JSON directly. JSON's pretty simple to use, so it's not really a big issue there. Anything else? Well, it's 12 o'clock. I think it's time for lunch. Thank you very much. Oh.